Read question, draw the diagram. Is asking, so what is the temperature rise of chamber C when we supply Q heat? Okay, we'll do one thing. We'll find out the total Q heat supplied by the heater coil. So then identify what process the gas will undergo in each part. Finally, I think this is what we have to check for it. Okay, let me get the diagram. I'll set up the diagram. Meanwhile, you can try with the question. Okay, this is what the okay. Let's bring the heater coil. There's the heater coil. Piston one is fixed. Piston one is fixed and diathermic. What do you mean by diathermic? Okay, piston one is fixed and it is diathermic. Okay, I'm not showing it being displaced. It is there only. Piston one is fixed and diathermic. Two is movable and diathermic, whereas three is movable and adiabatic. I don't know. I'm just making a guess. Maybe finally it will be off like this. Okay, let's get into the chamber A, B, C, same A, B, and C. So what was the initial volume V naught, P naught, T naught? And here also atmosphere is present. So what is the pressure will be P naught. There's a condition. So initial length, let it be L naught. May not be needed. Okay, let me. So this final length, let it be X1, length of this be X2, length of this be X3. Okay, let's get into one by one. What process the gas will undergo in the chamber A? Very fast you have to tell. What process?
Isochoric.
Isochoric.
Isochoric. Okay, good. Yeah, isochoric. I'll write it here. What about B and C? So here also that air will be there. No, the air will not go anywhere. So atmosphere is present. Very nice, simple problem. Okay, now finally there's a condition. So what do you expect here? So P naught S will be the thing that the air will exert a force on the piston. Okay, we have here piston 1, 2, piston 1, piston 2, piston 3. Okay, I think you almost we are going to end up this problem now. Okay, there's a piston 3, 2, and this is 1. Okay, now look at this. Finally, there's a final. Look at the second part of the diagram here. So here the air will exert force P naught S. So this is at equilibrium means what should be the pressure in the chamber C finally? Should be P naught only. Should be P naught only. So here. One condition is what that is being mixing. Find K. Assume assume all the process are quasi-static. He has to say this, otherwise, what happened? All the processes are quasi-static, means they take place very slowly. This piston, it will not accelerate, it will move slowly. This will also, it will move slowly. So when it moves slowly from rest to rest, so what will happen to pressure of gas will remain same, P naught. Now, similarly, if this is also movable, it's a movable piston, means net force on it should be zero, no? Because only pressure force, air and pressure force of the gas is acting. So final pressure here should also be same. And look at that, what is telling? These two are conducting. Like a piston one is conducting and fixed. So what do you expect the final temperature? Should be same. And what about two? The two is also conducting, so the temperature should be same. So here the pressures will be different, no doubt. So pressure here I'll write P1. So what is the pressure in the chamber? B and C remains constant. So what process it is? Isobaric. Straight away, I think we have to jump into the problem. What is that total heat supply? The temperature rise of chamber C when we supply the heat Q. He's asking temperature rise, that one. So total heat supplied is how much? Q amount of heat is supplied. So what all the heat supplied? A part is used to rise the intensity of each part, and also there's a work done. How to get the work done? This is a very difficult thing. Of course, we know pressure is constant. Pressure in the chamber being constant, we know how to calculate work done. So shall we directly use formula? Isobaric process formula. The total heat supplied should be equal to delta UA delta UB plus work done in the chamber B delta UC plus work done in the chamber C. So what is delta UB plus W? Should be equal to heat. This should be equal to QB, QC. What is delta UA? Okay, quotient. This is gamma. So this will be okay, R by gamma minus 1. We don't have any information what is the type of gas. So delta U should be equal to NR gamma minus 1 T minus T naught. What is the formula you can write? I'll do one thing. Let me. To make problem very simple, you need not to do so. Because in what is the heat absorbed in isobaric process? NCP delta T. In isochloric process, NCV delta T. So T minus T naught. Have same gas. Initial volume and temperature of each chamber is V naught T naught. So number of moles must be same. NCP delta T. T minus T naught. NCP T minus T naught. Solve for this. So number of moles P naught V naught by R T naught R by gamma minus 1 T minus T naught. P naught V naught R T naught. CP, what shall I write? R gamma by gamma minus 1. Gamma CV, it should be. So therefore, gamma R by gamma minus 1 T minus T naught. P naught, V naught. Okay, this from here, 2 will come. R will get eliminated. So P naught, V naught, gamma minus 1, T minus T naught. This much is what I'll take outside. Let's see that afterwards what we'll get. 1 plus 2 gamma. Okay, we don't know that T, no? What to do with that T? We don't know that T. Anybody, how to bring that temperature? Yes, and I want
Number of
some
moles.
number of moles. There should be T naught in the denominator. Ma. T naught should be there. Okay, yeah, T naught will be there. Okay, okay, fine, yeah. Okay, number of moles in a given chamber must be constant. Okay, is it x1 equal to L naught chamber A? But again, we don't know pressure. Okay, I'll jump into the problem like this. What will happen to total number of moles of a gas? Okay, in each chamber, okay, we'll go for chamber A. In chamber A, what is the equation we can write it? P naught, V naught, RT naught. V naught is what? S into L naught. Volume, no? Final pressure, P S into same L naught RT. Because it's an isochoric process, no? So therefore, what is the equation we'll get? P naught by T naught equal to P by T. Keep this. Okay, this is one, this is equation 2. Keep in mind, chamber B. Let's see in each chamber, what is the P naught, SL naught is equal to RT naught should be equal to, pressure is how much will be P naught only there. S X2. Here R T. So therefore, P naught by T naught is equal to, P naught get cancels here, no? Here the equation will be X2 is equal to T by T naught into L naught. L naught is what we assumed it. Later on we can eliminate that also. Chamber C. P naught SL naught RT naught equal to P naught SX3 RT. X3 is equal to, okay, I have this much of information. So X2 equal to X3 I'm getting. Okay, now, so we wanted T, no? We didn't bother about any other parameter here. So in fact here, therefore, X2 equal to X3. But we need only T, that's all. From where to bring that T? Okay, look at once. What is asking? Is it needed? Temperature rise is asking. So already we got answer, no? Temperature rise is asking. What do you mean by temperature rise? T minus T naught only is asking. Huh? He didn't ask temperature. He didn't have that one. You see, like the temperature rise of the chamber seat. T minus T naught is asking. Okay, I think this only we should rewrite expression for that, and we have to simplify this one. Okay, anyway, but they may ask you length of the chamber. That's why I just wanted you to think this one. Okay, we'll do one thing. I'll just push. We'll rewrite this one. So this will become Q. Okay, all the things are there. So what is the value of K now? K will become 2. Answer will be 2. Okay, there's a thing. Okay, leave it. Okay, if they ask you anything further, no, length of the chamber, something, we have to use this particular method here. Read this question. Carefully read it. Some idea of spring is what I brought there.